So up on the board here, I've got the graph of cosine. I just reminded us, here's our unit circle. When our angle is 0, its terminal ray will be on the positive x-axis, and cosine is just picking out the x values. So cosine starts at a value of 1, and then it moves down to 0, and then down to -1. Okay, so here I want to try to sketch the derivative, whatever that is. So I'm going to just work with this first period from 0 to 2 pi. Not really the first period, but this standard period. Looks like we start out going down. And we go down until we hit pi. Let's fill in these quadrantal angles. And then we're going to go up, and we go up until we hit a high point at 2 pi. And of course, I know that when the derivative is going down, that's going to mean that when the function is going down, that's going to mean that my derivative is negative, so the graph will be below the x-axis. And when the function is going up, my derivative will be positive. Okay. And all of these transition points, just like the transition points for sine, are actually very nice, smooth, rounded curves. So we're going to be at 0 at those points. Now, if I look at steepness, I've got my 2 steep zones, and then not so steep when we're close to 0. It looks like the graph of cosine starts out not so steep, gets steeper in the middle, and then gets less steep again. So between these two zeros, we're going to dip down to moderately steep and then back up to 0. Not so steep, steeper in the middle, not so steep. So again, we just sort of bump up to the moderately steep zone, and then it's going to continue. If cosine was periodic, its derivative, which describes that periodic behavior, is going to have to be periodic as well. Now, that's not the graph of sine, because this interval from 0 to pi over 2, this interval from 0 to pi over 2, since I'm putting on the horizontal axis my angles, that interval corresponds to angles that when I represent them rotationally would land in quadrant 1. And in quadrant 1, I know that all my trig functions are positive. So the derivative of cosine can't be sine, because the derivative of cosine in quadrant 1 is negative. But if I look at this, that really looks like the sine graph just flipped upside down. It looks like we've got sine multiplied by -1. So based on the graph, an educated guess for the derivative of cosine would be some negative multiple of sine. And in the next video, we'll look at the limit definition and actually either confirm or not confirm that guess.